All right, so yeah, as you said, I'm Tom. I'm the lead engineer at Rasa. And I want to give you a short overview over conversational AI agents and how to build clever chatbots. And especially how to get started with few data samples, few conversations, and just not a lot of data to get started with. I mean, there are a lot of models out there, but how do you get started with only 100 training examples? So here's an example of what we want to achieve. So the user says hi, and then he tells the bot, I just moved. And we assume he wants to change his address, right, with our company. And he's providing the address Oxford Street 20, which is unfortunately not a unique address. So one is near Harvard University, but that is actually not the one the user wanted to use, right? So he's actually moved to London. And what the bot did here is it recognized, OK, no, so it provided the wrong address, used the additional information from London, combined that with the previous information to then suggest the correct address, right? And as you can see here, this is only a pretty simple dialogue, but there are so many different paths through that dialogue. So a user can provide the complete address at once. He can provide the address in multiple messages or provide a wrong address, all this stuff. But the idea is that conversational AI will dramatically change how users interact with software, right? So they define what happens next. They define how the workflow happens. And that's quite different to a web page, right? So in the web page, you design it, and the user needs to find the information he's looking for. In a chat, he is describing his need, and you can provide, by analyzing that message, you can provide him with the information he's looking for. All right, and yeah, we created an open source framework for that, which is based on a lot of open source tools. So there's sklearn, Keras for our machine learning models, TensorFlow. And yeah, check it out on GitHub. It's on Rasa HQ, Rasa NLU. And I want to have a look at the architecture and the different parts of the framework, so the natural language understanding as well as the dialogue handling. So here's an example. What's the weather like tomorrow? Can we text or voice? It comes in through channels, so Facebook or whatever. And the first part is natural language understanding, which analyzes the message and extracts structured information, right? Intent, entities, any information the user wants to convey. I don't know, semantic analysis is done in that part. And then there's the dialogue management, which combines the knowledge across multiple messages, right? And it can collect further information from a backend. So in this example where we have a weather API, we would then, after we have all the information about the place and the time the user wants to know the weather, we can then query a database and get a result out. And at the end, there's natural language generation. So after we know what we want to do and what we want to convey back to the user, we need to somehow generate text or speech that the user can then read and get his information out of. So in this example, it would be up is sunny and 20 degrees. There are a couple of alternatives like API AI with AI and Louis, which are just hosted solutions. And the difference is we try to make it open source so everyone can contribute and customize it for their needs, right? So first of all, I want to have a look at the natural language understanding and dig a bit deeper into that topic. So as I said, the goal is to get structured information. So what we can see here is the different messages about restaurants. So I'm looking for a place in the north of town. And what we want to extract are entities, for example, north, center, Chinese, Mexican, stuff like that, and the intent of the whole message. So that could look like that, right? So we got the text, intent, and entities there. Pretty simple. But how does that work? So if you start out with few data samples, the question is how do you process the data? And the key is to rely on pre-trained models as long as you can, and only for the pieces where you cannot do that, rely on simple models for your domain. And as you collect more and more data, move to more and more complex models to improve the performance. So the pipeline for the intent classification is rather simple. There's vectorization, right? Skip-gram model, word-to-vec, pre-trained model on one of the large corpora like Wikipedia or news corpora, and then do the intent classification. All right, so it's pretty easy. And backs are your friend here, right? So when we start out with few data samples, we try to just average the words, right? Which works pretty well for small data sets and for simple examples. But as soon as you collect more data, you can then move to more advanced models like recurrent neural networks, feed in the words one after another to actually keep track of word order that you lose when you average over the words. Right, so this is the idea, right? So message comes in, bag of words. Then we get our linear or SVM or neural network, or later a recurrent neural network. And then the output is the intent of the message. So in our case, would be request whether. So that's pretty simple. But what happens if there are words in there that you don't know, right? So that's a huge problem with like these pre-trained work vectors and chat interfaces, because users tend to like misspell words or just use words that don't exist or emojis or stuff like that. And usually they aren't part of any word vectors that are pre-trained. And a couple of different solutions, one that works quite well on smaller data sets is to build like character n-grams, right? So you collect the n-grams that are most informative, like using TF-IDF, and then encode them one hot and embed them and add them to the representation of the vector that you extracted from your pre-trained model. Yeah, this is one solution. Another solution would be using LSTMs, character LSTMs, training them on a data set if you have more data down the road. And the second part is the entity extraction pipeline. So out of that sentence, what's the weather like tomorrow, we also want to extract tomorrow as date, because we need that to query our API. And here the pipeline is a bit more difficult, because when we train our model, we want to train it not on all the possible words for that date field, right? So we don't want to train it on today, every date that we've seen, like years and months, but rather we want to have a look at the part of speech tag and the structure of the sentence to generalize the pattern we have seen in the sentence to other sentences that didn't occur in the training data set. So what we do is we tokenize the sentence. We annotate it with part of speech tags. We use a chunker to combine the different pieces of the sentence that belong together. Then we use named entity recognition, for example, conditional random field, do the entity extraction, and then we got our date, which is tomorrow in that case. Yeah, I want to go do a quick demo just to show how simple it is. What you can see here is just defining a pipeline, a processing pipeline. So a message comes in and goes through different components, machine learning components. So first of all, there's just an initialization, so loading word vectors. Then we got our named entity recognition using a conditional random field. Then we got a pre-trained pre-trained model from Spacey that's trained on persons and locations and dates and stuff like that. We got a featureizer here, which uses n-grams and SSR word vectors trained on I think, Wikipedia. And then we got our intent classifier Spacey. All right, so yeah, let's do that. So this is a training. It's going to be pretty fast, because what takes most of the time is just loading the vectors into memory. It's a pretty small data set. It has only 40 samples, as you can see here. So we got 40 different samples in here, 4 distant intents, so affirm, goodbye, greet, and restaurant search. And we also got 2 different entities, which is cuisine and location. And as you can see, it trained pretty quick. It's actually doing a grid search over an SVM, but as I said, just 40 samples. So. Yeah, let's try it out on that example, which is not part of the training data. But as you can see, even though we only have a small data set, it's due to the simple sentences that are usually used in chat messages, it's possible to rely on smaller data sets and still be able to recognize named entities. Like in this case, we got Mexican from our NER CRF, and the pre-trained model recognized Potsdam as a city, so it's pre-trained on other cities and countries and stuff like that, and it's a restaurant search. All right. Cool. Now I want to have a look at the more interesting part of the dialogue handling, because the natural language understanding is pretty much solved for these simple messages. And as long as you collect more and more data, you're fine there. But the dialogue handling is a bit more involved. So the usual systems use handcrafted rules. So you define, OK, this is the message I've seen, and this is what I'm going to do next. But that gets pretty complicated, even for simple examples, as I've shown you for the address case. So one solution is to go data-driven. So here's an example that goes into a bit of a different direction. But as you can see, the machine combines the knowledge from the message and responds accordingly. And that data is collected and fed back into the machine learning model to train it and refine it. Yeah, this dialogue shown here is a bit different from what we're actually doing and what we want to actually achieve, because this is more of philosophical and interest kind of dialogue, but we're actually looking for goal-oriented dialogues where we actually want to achieve something and solve a problem for the user. So how does the dialogue handling look like? So here's a pretty simple graphic how that works. So we got our message and the structured data out of that message. We combine it with the state we've collected across all messages, and that calculates the next action. So it's pretty easy, and that can be an SVM, a current neural network, depending on how much data we have. And that next action then creates the output to the user. So in this case, it will be sunny, 20 degrees, and updates the internal state. So that's the whole idea. Next message comes in, we use the internal state and predict the next action. So this is the whole flow that all of these dialogue systems use to predict next actions. But I want to have a closer look at what the models look like and how we generate the data that goes in there. So as I said, first intent classification using SVMs, then entity extraction, and then feeding that data into the current neural network. So we tried LSTMs, and they worked pretty well, even on small data sets, overfeeding them pretty harshly, though. Right, so this is the first input for our LSTM. And the other inputs are API calls, the data we gather from there, serializing that using a feature Rasa. And entity output our action generates. Then usually there's an action mask, because models tend to be wrong and predict actions that aren't correct. And sometimes you want to enforce security regulations and stuff like that. And so you mask out a couple of actions there if the prediction isn't actually what you want and looking for. And then re-normalize to get probabilities again. You sample from that distribution during training, and prediction you just take the max. And yeah, depending on the action, we now either do an API call, adding further information to our loop and to our recurrent neural network. And basically, we keep predicting, and we're going to stay in that loop until we predict a special action, which is usually called listening or something like that, and which just says, OK, we're going to stop our loop, and we listen for the next message from the user. In this case, our bot might create the response, it will be sunny and 20 degrees. Right, so this is the idea that works here. And in this example, we might do 3 loops. The first one is user message comes in. We go to the API from a weather provider, get that data, feed it in back into our LSTM. We see that the API provided a result, hence the LSTM should predict that the next action is, OK, feed that information back to the user. And then the third prediction would be listen to the next user input. But how to get started, right? So how do we generate training data? Usually when you create an assistant, you don't have any data. So you might be able to create messages, which is pretty easy. So collecting data about greetings, goodbyes, and stuff like that, and what's the weather like tomorrow, or how's the weather going to be. But you still need training data for the dialogue. And the solution here is using online learning. It's one solution, it's not the final solution. But as soon as the bot does something stupid, how did you like it? So, which doesn't really make sense in that context of the message from the user. We can assume in this example that we understood the message correctly, so we got the correct intent and correct entities, but the state is wrong, right? So we predicted the wrong next action. And what we do is we correct that behavior and retrain the model. So it's pretty simple. So labeling it directly and adding that to the model again. For the LSTM, that works pretty well. Right, and then we use the retrained model to predict the next action, which should then be corrected and hopefully the right one. Okay. Yeah, I want to show that as well. Okay, cool. So what's happening is the data is getting loaded and the LSTM is pre-trained. So it's like pre-trained on I think like 10 dialogues or something like that. And what happens now is the script just loads user messages from a file. So there's just a file of a couple of lines of like random user messages. So the user is not actually responding to what the bot is saying, just providing random answers, which can happen in real life as well. So that should be good for the example. And what you can see here in green is what the user said, which is just greet. So this is already showing the intent. In the middle, we can see the slot, so the state of the bot, what internal information it has stored. We cannot see the representation of the LSTM, right, because that's internal and not really readable, but we know which information we feed in. And now the bot wants to do a search, which doesn't really make sense because we don't have any information yet about what the user wants to do, so you can just correct that. We didn't really invest in a lot of UI here, but it should show the principle though. So first we want to do say hello, greet them, so it should be 2, I think. So hey there, yeah, and then we want to ask him how we can help him, which is 5. And then we should listen, so that was a correct prediction, so good job there. And now the user provided us with location Rome and price cheap, so this is what he's looking for, the restaurant he's looking for. And we stored that information internally, and we're going to feed that into the LSTM now. And now the prediction was listen again, which is not a good idea. And we can see that the predictions already start changing, right? So in the beginning, there was pretty uniform distribution. And right now, it starts changing and moving towards the action I already used. So what I want to do, so yeah, I need to query the user for the number of people for the restaurant he's looking for, which is number 7. And then we're going to listen for the user's input. Right, so the user now is providing that the cuisine is going to be Spanish, which is not what I asked for, but it's okay. We're still going to store that. And the bot now wants to do ask num people again, which is actually a good idea. But then we need to listen again. Okay, cool. Right, so now we got that information about people 6, so that's good now. And I think we got everything filled. So we have a cuisine, people, a price, and a location. And so the next thing we're going to do is we're going to do the search. And then we're going to search. And then we're going to suggest that. OK, so now the whole flow is finished, right? So the suggestion is Papa's Pizza Place from the bot. And now the bot is finished and should listen to the next user inputs. And now the user starts changing his stuff again because it just doesn't listen to what the bot is saying. But it's OK, so it's a normal user behavior, which would just as well could just change the query to a different price in this case. So now it's price expensive. So yeah, that's the whole idea, and as you can see, again, so the probabilities keep changing, and it should adjust to the flow I provided to the bot. Yeah, yeah. This is the whole idea of how to train a bot when getting started. A few training samples, and what you would then do is during your rollout, you just collect more and more data about the dialogues and use them for further training. Cool. Yeah. Yeah, so a couple of final thoughts here. So there's still a lot of open challenges here. So for example, the combination of different dialogue models. So what I've just shown is one dialogue model that is usually task-oriented, but ideally you also want to have a chit-chat model. So users tend to ask questions like, how are you, or what's your favorite food, or something like that. Favorite color is really common as well. And you actually want to reuse these trained models, and that's a tough challenge because you need to decide when to use which model and when to switch between the models. And that's what we're looking at in the moment. Then you got your unsupervised multi-language entity recognition, so that would be ideal. So annotate your entities in one language and then transform your bot into a new language without a lot of work. But yeah, challenging part. And then there's dialogue generalization. So there are a couple of patterns in dialogues that keep repeating. So this is, for example, if we want to do this weather API call, the user needs to provide location and a date. But it doesn't really matter in which order the user provides that. And this is like a common pattern for these types of bots. So no matter in which order the information is provided, it should work. And yeah, usually you want to augment your training data set to account for that, so you don't need to specify it all at once beforehand. Right, yeah. So there are a couple of good reads out there, and I think the PDF is going to be published afterwards, so you can have a look at the links. So there's Last Words, which is computational linguistics and deep learning, which is a blog post, which is a pretty good read. There's memory networks, which is the base for most of the state-of-the-art papers on that topic. It moved further down the line to end-to-end networks now, but they aren't there yet, especially for smaller data sets. So basically, instead of having this intermediate part of natural language processing and intent classification, you directly feed in your character stream into your dialogue management system, right? So no pre-classification there, but really end-to-end from message to action. But yeah, as said, on smaller data set, it isn't there yet. We can't really use that yet. So that's the paper I referenced here. And then there's MEM end-to-end in Python, which is a really good visualization. So if you want to have a look at that, it's quite a cool project. And it's open source as well. Yeah, three thoughts to take home with. So there are a lot of techniques to handle small data sets. And really the key is to rely on pre-trained models, and that's what we try to do. And get started with conversational AI quickly. And then move on from your simpler models, like using an SVM for intent classification, and then move on to more complex models, like taking word order into account, using LSTMs or other recurrent neural networks. Right, and these more advanced models, we tried it out on the baby Facebook data set, which is like a restaurant search data set used for performance measurement for dialogue systems. And really these deep techniques of recurrent neural networks help to advance the state of the art there in processing and predicting next actions for these assistants. Yeah, and really abandon flowcharts, so that's not a good idea, even to get started with. The bot will quickly not know what it should do. You will not think of all the cases, and you just fall through your if and else statements. So data-driven dialogue analysis is really the future here, and what we should aim for. Yeah, that's about it. So really get in touch. Have a look at the open source project. We're going to open source the dialogue part as well, so the training and how we use the algorithms there. And yeah, check it out. Talk to me if you have any questions afterwards. And we're actually hiring, so looking for data scientists, machine learning engineers, and yeah. Thanks.
Thank you very much. Are there any questions? Hi,
Hey.
Thanks a lot. One thing I was wondering, because you said don't use flow diagrams,
Yeah.
But how large is the weight of the intent in determining the next action? Isn't that the main driver of what the next action will be?
Yeah, in the beginning, really it is. But when you tend to do more complex dialogues, that like, for example, let's imagine dental insurance, right? The user needs to provide a couple of different pieces of information, so his age and stuff like that. You will have questions like, is that right, or something like that, where the intent is just affirm or something like that. And then the intent itself doesn't really tell you much about the next action. But for these simple cases, for the restaurant search, for example, you're completely right. So if the user says, I'm looking for a restaurant, then that most certainly the next action is search for a restaurant.
So then it will resemble a flow diagram, basically.
Yeah, that's a pretty simple example. But that's what we do with our LSTM when we train it. So we overfit it to be like a flowchart, right? So it's really looking for the data we've seen in the training set. And then as we collect more data, we then move over to stop the overfitting and to make it more generalizable, that it handles cases it hasn't seen during training. Yeah.
Nice talk. I was a bit confused. I didn't really understand how do you train the system to recognize intent. And I mean, intent can also be something very broad. I imagine that you define it depending on the domain of the bot.
So you mean how we do the intent classification?
Yeah, exactly.
Right. So that should be that one, or no, the one before. So what we do is we take in the message, featureize each word using Word2Vec. Then we usually append features that are more reflecting out-of-scope words or out of vocabulary words, using n-grams, using character LSTMs, create a new word vector for each word, then combine these. For simple models, just averaging them, right, bag of words model, and then putting them through an LSTM. Not an LSTM, an SVM.
Okay, I see. But I mean, there you have like 5 different kinds of intents. I mean, but I imagine there are bots where you have, if you want to go through a booking of something really important, you have, can you check, do you want to change something? I mean, those things must be hard to train all those intents.
Yeah, so the system we work with so are around like 100 intents, so that tends to work pretty well still.
Okay, and do you have anything to generate the training data automatically, or you go to all the examples and you annotate yourself when you want to get training data?
So in the beginning, we really start just writing samples. So the first samples are just written by humans. Then the next step is usually that we like go Amazon Turk and provide a couple more training samples, and then we do like automated labeling and correct.
Okay. Have you thought about using active learning?
Sorry?
Have you thought about using active learning?
No, we didn't. Might be a good idea, yeah.
Okay.
Mm-hmm.
Thanks.
Thanks.
Any other questions? In that case, Hi,
hey.
that's a great talk. I wondered, it looked like your dialogue training, the dialogue handling training was using something that looked like a reinforcement learning sort of setup. I mean, was that part of the way that the sort of structure that you were implementing, or how was it different? Or maybe I didn't understand.
So it was a bit hard to understand because you didn't keep the microphone at the mouth. So just let me repeat and just correct me if I'm wrong. Are we using reinforcement learning for the dialogue handling?
I mean, it looked like reinforcement learning sort of formalism, and I was just wondering if that took part in your
Right. So we've tried it out, and we're actually experimenting with that with a couple of data sets, but we haven't like added it to the framework yet. But we're really thinking about it. But this is really just online learning, so using the LSTM and then adding a couple more training samples, training it on a further batch, like sampling in a couple of more training samples from the original data set, so that the LSTM doesn't keep forgetting the original training data. And that basically is just an online learning algorithm. But we're actually thinking about reinforcement learning as well. Yeah. Cool.
No other question from the audience. I have one. What's your business model? How do you, as organization, earn money with this?
Right. So what we do is we try to open source all the stuff we use for our dialogue handling and natural language processing. And we do projects with larger corporates like UBS, Helvetia, and insurance companies. and provide them first with customized solutions. So really working on their problem, finding out, okay, what's the custom solution for them, because they just really don't know how they can use conversational assistants. And the second part really is we provide a couple more tools for enterprises, like monitoring and stuff like that. Right? But really tools for startups or like personal projects are there and can be used for, that's the idea.
Great. Let's thank our speaker again.